and I'm here to go over the Chapter 4 test solutions with you. Here we go. Alright, so first off we were asked to tell whether each table represents a function and explain how we know. Okay, this first one is a function because each input has exactly one output. I mean, as best we can tell, every time we enter in 0 we're going to get 13 because I don't even see another 0 on here. Every time we enter in 1 we're going to get 11. Every time we enter in 5 we're going to get 3. So it is a function. Same thing with this one. Is a little bit tougher, but it is a function. Each input has exactly one output. Every time I enter in -3, I'm going to get 9. Every time I enter in 0, I'm going to get 0. And every time I enter in 2, I'm going to get 4. It does not matter that two inputs share the same output. It does not matter that both -3 and 3 give us 9. And on C, this is not a function. The key thing here is that the input 2 has two different outputs. When you input 2, sometimes you get 8, and when you input 2, sometimes you get -8. That makes it not a function. Last thing here on whether something's a function or not, Susan made up the following coding rule. Take each letter of the alphabet and advance it 5 letters. Does this rule describe a function? And explain how we know how. So I said that yes, this is a function because each letter, our input, will be assigned one different letter. Or maybe it's assigned a different number, but so yeah, every single letter is going to have its own output. It's going to have one output, so that makes it a function. Alright, so we've got a relation that has a domain of -3 and 5, so the x has to be between -3 and 5, and the range is -2 to 4, so it's got to be between -2 and +4. And the x value -1 corresponds to the y value -1. We're supposed to graph a function that fits this description. So here we go. So again, from -3 to +5 for our domain, and from -2 to +4 for our range. So my function has to go all the way from the top of this box down to the bottom, and it's got to go all the way from the left to the right. Also, one thing that a lot of people messed up on is they forgot to include the point -1, -1. It's got to run through this point right here. So I just went ahead and started at the top. I went to that point, continued going to the bottom, and then took it all the way up to the top right corner. I thought was the easiest way for me to do that. That is a function that meets all that criteria. On part B, we're supposed to use the same criteria but make it so it's not a function. So again, my relationship here goes all the way from the -3 to the 5. It goes all the way from the -2 to the 4. It also goes through -1, 1, but it is not a function because it does not pass the vertical line test. In fact, every input from -1 to +1 has 3 different outputs. 1, 2, 3. So everything from -1 to +1 has 3 outputs. That makes it not a function. Alright, we got Darnell and his energy level at the school day. When was his energy level the highest? Looks like right up here, so 2 o'clock p.m. When was it rising the fastest? It looks like I'd say this little span here. So I said from noon to 1. Some people, nobody really said that it was rising very fast from 8 to 8:30 too. I think most people were drawn to this. Some people said all the way from noon to 2, but it really levels off here from 1 to 2. So I think this is the fastest here, this short time frame. Immediately following 12 p.m. I accepted that too. When was his energy level the lowest? Right here at noon, and we're supposed to give a reason why it might be the lowest. Well, noon's lunchtime, so he's probably hungry. He probably hadn't eaten since 8 a.m. perhaps, when his initial energy initially started rising, and he needed to eat, and he had lunch, and boom, his energy level went right up. When was his energy level decreasing? Well, I see 2 different instances where it's decreasing. I'd say from about 9 a.m. all the way to noon, and between 2 p.m. and 3 p.m. I'd say that's about 3 p.m. So 2 different instances. You had to state both. The dependent variable here is his energy level. His energy level is dependent on the time of day in this case. All right, we got two lines. We're first asked to give the slope, the y-intercept, and equation for each line. So line A has got a slope of -1. It goes down 1 over 1, down 1 over 1. It's got a y-intercept of 2. So if we wrote this in slope-intercept form, which would make sense because we just figured out the slope and the y-intercept, it would be y equals -x plus 2. -x plus 2. Line B has got a slope of 1/3, meaning it goes up 1 over 1, 2, 3, up 1 over 1, 2, 3. It's got a y-intercept of -2. There it is right there. So written in slope-intercept form, its equation would be 1/3 x minus 2. All right, and the point of intersection is going to be right here, which is 3, -1. 3, -1. All right, so we got the equation of a line in point-slope form given to us, y equals 7 minus 2 times x minus 5, and we're supposed to figure out the name the point on the line with an x-coordinate of 3. In other words, plug 3 in for x, and when we do that, when I plug 3 in for x right here, 3 minus 5 is -2. -2 times -2 is positive 4, and 4 plus 7 is 11. I get an output of 11 when my input is 3, so here's my answer right here, 311. What about naming the point on the line with a y-coordinate of 5? So now we have to let the output be 5, so we have to let y equal 5 right here. So I subtracted 7 from both sides. 5 minus 7 is -2. I divided both sides by -2. -2 divided by -2 is 1. And then I added 5 to both sides, and it's 6. And there's my point, 6, 5 right there. So when the input is 6, the output will be 5. By the way, I went ahead and graphed the equation, and I used the trace function to figure out that when x is 6, y is 5, just to check myself. And I did the same thing up here, graphed the function, and I typed in 3 on the trace function, and the 11 is the output. So, I mean, why not check yourself if you have access to the graphing calculator? And then lastly, you're supposed to use the point you named in 6b to write another equation of the line in point-slope form. So we already know the slope is -2, and we're just going to use x6 and y5. So here it is. Y equals 5 minus 2 times x minus 6. The 6 goes right there, and the 5 goes right there. By the way, I also went ahead and since I already had this equation in, the 7 minus 2 times x minus 5, I also plugged in this equation, and then I looked at the table to make sure that the outputs were the same for both equations. Explain how you can find the equation of a line when you know the coordinates of the 2 points of the line. Well, if I know the coordinates of 2 points, the first thing I should do is find the slope of the line by finding the change in y divided by the change in x. Once I have the slope, I can use the slope and one of the points, I don't need them both, but one of the points to write an equation in point-slope form. And once I have an equation written in point-slope form, I can convert to slope-intercept form by distributing and combining like terms. So I was looking for something like that in your answers. Solve this equation using any method and use another method to check your solution. So here's the first method I used. I used the balancing method here. So first thing I did was multiply both sides by x plus 2. I got this equation. I then simplified the left side. 5 minus 11 is -6. I divided both sides by 3. -6 divided by 3 is -2. And then I subtracted 2 from both sides, and I got -4. And to check the answer, I did something a little bit different here. I used an undo table. The first thing I did, though, is I flipped the whole thing over. So instead of x plus 2 on the bottom, I put it on the top. Instead of -6 on the top, I put it on the bottom. And instead of 3, I made it 1/3. So to get, after I pick x, I'm going to add 2 to it, and I'm going to divide by -6. Undoing that would be multiplying by -6 and then subtracting 2. So 1/3 times -6 is -2, and -2 minus 2 is -4. And there we go. So 5x minus 20, y equals 5x minus 20 in factored form, so the coefficient of x is 1. Well, that means we have to divide this 5x by 5, and whatever we do to one term, we have to do to both terms. So we'll just say 5x divided by 5 is x, and negative 20 divided by 5 is negative 4. So y equals 5 times x minus 4. That would be it in factored form. Writing this equation in intercept form, so first thing I'm going to do is distribute that 14.7. 14.7 times negative 20 is negative 294. And then, I think I got a mistake here, don't I? Let's fix this. How about 130.6? And then I'll check my math here. Negative 294 plus 130.6, negative 294 plus 130.6, I got my calculator going here, is negative 163.4. So negative 163.4. So there's what our answer should be in intercept form. All right, write y equals 6.2x minus 17 in point slope form using the point with an x coordinate of 8. So the first thing I got to do is figure out what the y value would be that corresponds with an x coordinate of 8. So I'm going to plug in 8 for x and figure out that y is 32.6. Then I can do point slope form. It's going to be y equals my y value, 32.6, plus my slope, 6.2, times x minus 8. So this is the answer we're looking for. Properties illustrated here. That is the commutative property of multiplication, that you can multiply in any order and still get the same thing. 6 times 8 is 48, just like 8 times 6 is 48. And for 10b, this is called the distributive property, that 6 times the sum of 8 and 4 is equal to 6, the sum of 6 times 8 and 6 times 4. All right, 11. Jamie spent the summer in Canada. Because Canada uses the metric system, he wanted to be able to convert Fahrenheit temperatures to Celsius temperatures. He remembered from science class that the relationship between the two systems is linear. He also remembered that the water freezes at 32 degrees Fahrenheit or 0 degrees Celsius and boils at 212 degrees Fahrenheit or 100 degrees Celsius. So good for Jamie. So let's show how we can write an equation in point slope form for converting Fahrenheit temperatures to Celsius temperatures. Well, the first thing he needs is his slope. So the change in our Celsius temperatures, or y values, would be 100, and the change in our Fahrenheit temperatures would be 180. So we get 5/9, okay, which is 0.5 repeating, but I would definitely leave it as 5/9. I think it makes a lot more sense. All right. And here's two different forms we could use for point slope form. As you can see, I left B off, so I'll just kind of tell you the B. They wanted us to know what's the real world meaning of the slope. Okay, so this means that every time the Celsius temperature goes up by 5 degrees, that the Fahrenheit temperature will go up by 9 degrees. Or every time the Fahrenheit temperature goes up by 9 degrees, the Celsius temperature will go up by 5 degrees. Another way you could say it is that every time the Fahrenheit temperature goes up by 1 degree, the Celsius temperature will go up by 5/9 of a degree. But I think it makes sense to talk about it as change in Celsius over change in Fahrenheit. So what's the Celsius equivalent of 68 degrees Fahrenheit? Well, I'll plug 68 into this equation. It looked easier for me to work with since they're both the same. And I'll subtract and get 36, and 5/9 of 36 is 20. So 20 degrees Celsius. Also, on a very warm day, the temperature is 40 degrees Celsius. What's the Fahrenheit equivalent? So this is where we're given the y value here. And the first thing I did was multiply both sides by 9/5. So 40 divided by 5 is 8, and 8 times 9 is 72. And then I added 32 to both sides, and it's 104 degrees. So just like they said, on a very warm day, 104 degrees Fahrenheit. I know that's pretty hot out. Coming down to the end here, Isabel, a research assistant at Maryland State University Museum, measured the metacarpal 1 bone and the height of 10, not often, 10 human skeletons. Anthropologists can use data such as these to conjecture a person's height based on partial skeleton remains. So we're going to use our calculator to make a scatter plot and sketch a graph and describe the window we used. Okay, so here's my scatter plot using a window from 35 to 55 scaled by 5s and from 150 to 190 scaled by 5s for my y values. So it looks kind of like that. 5 number summaries. For the metacarpal 1 lengths, 39, 42, 45.5, 50, and 52. And for the skeletal heights, it's 157, 169, 172, 176, and 183. So the coordinates of the Q points we should use are 42, 169, and 50, 176. All right, so we're going to find the slope of the line through those Q points. 7 over 8, which is about 0.875. The real world meaning of that is that every time the skeletal height goes up by 7 centimeters, the metacarpal 1 length goes up by 8 millimeters. So I think the fraction is the easier way to talk about the real world. But a lot of people said that every time the metacarpal 1 length goes up by 1 millimeter, the skeletal height will go up by 0.875 centimeters. Similar. I used the decimal for my equation, so I plugged it into point slope, and then I converted it into slope intercept or y-intercept. Then lastly, we were asked to graph it in the same window as our scatter plot. So I've done that. This is what I get. I don't like it. And that was the next question. So do we think the line is a good fit? Good model for the data? I don't think this is a good fit for the model. The slope needs to be steeper to match the trend of the data points. I think something like that would be a lot better. All right, and a writer for the West Branch Gazette is writing an article on new research that showed there's a strong positive relationship between the number of books someone reads per year and the number of friends. They give this model. Which of the following is the most appropriate headline for the article? Can we say that reading books will make you popular? No, we cannot say that. Just because there's a trend doesn't mean that one's causing the other. Can we say that non-readers have no friends? Same thing. Just because there's a link doesn't mean that one's causing the other. Can we say that lost reading means lost friends? Again, correlation is not causation, folks. Correlation is not causation. All we can say really is that the research shows a tie between reading and friends. So it's not that one causes the other, or that necessarily one's going to make the other one happen. All we can say is that there's a tie between the two. Okay, and we got one last question here. Find an equation that you think better represents the data for problem 12. So something that's better than this. So what I did was I ran linear regression and got a slope and a y-intercept, and a handful of people did the same thing as me, and I got 1.73 for my slope and 93.10 for my y-intercept. And I think you'll agree that when I plot that on my scatter plot that it looks a lot better, that the slope matches better. I got half the points above it, half the points below it. So there we go. I accepted other answers, but if you gave me an answer, I graphed it on the scatter plot and I decided whether I thought it was a good one or not. So regardless of your method. All right, that's all I've got for you today. I was able to keep it under 20 minutes somehow. Very long test, but hopefully this helps with any corrections that you need to do. I'll see you soon. Good luck.